8142. Three types of turbine blades are: A. An impulse, converging, and impulse converging. B. Impulse, reaction, and impulse reaction. C. Impulse, diverging, and impulse diverging. The correct answer is B. Impulse blades. Impulse blades are primarily used in impulse turbines. They are designed to extract the kinetic energy from the high-velocity fluid flow. The flow of the fluid changes direction as it passes through the blades, and the pressure drops as a result of the fluid's kinetic energy being converted to mechanical work. Reaction blades. Reaction blades are used in reaction turbines. They are designed to extract both kinetic energy and pressure energy from the fluid flow. The fluid passes through the blades, and the pressure drops gradually as it expands while doing work on the blades. The pressure drop is achieved through a combination of velocity change and pressure change. Impulse reaction blades. Impulse reaction blades combine features of both impulse and reaction blades. These blades have a combination of fixed and moving blades, where the fixed blades are impulse blades and the moving blades are reaction blades. The fluid flow undergoes both a velocity change and a pressure change as it passes through the blades, resulting in an intermediate pressure drop. 8143. Which statement is true regarding aircraft engine propulsion? A. An engine-driven propeller imparts a relatively small amount of acceleration to a large mass of air. B. An engine-driven propeller imparts a relatively large amount of acceleration to a smaller mass of air. C. In modern turboprop engines, nearly 50% of the exhaust gas energy is extracted by turbines to drive the propeller and compressor, with the rest providing exhaust thrust. The correct answer is A. A propeller produces thrust by accelerating a relatively large mass of air by a comparatively small amount. Jet engines accelerate a smaller mass of air by a larger amount. 8144. An advantage of the axial-flow compressor is its A. Low starting power requirement. B. Low weight. C. High peak efficiency. The correct answer is C. Axial-flow compressors are commonly used in gas turbine engines, including jet engines. They consist of multiple stages of rotating blades, rotor, and stationary blades, stator, that work together to compress the incoming air. The blades are designed in a way that allows the air to flow parallel to the axis of rotation, hence the term axial flow. One of the key advantages of axial flow compressors is their high peak efficiency. The design of the rotor and stator blades, along with the airflow path, helps in achieving a high compression ratio with minimal energy losses. The blades are aerodynamically optimized to efficiently compress the air, providing a high pressure rise per stage. Compared to other types of compressors, such as centrifugal compressors, axial flow compressors offer a higher overall efficiency. This means that they can achieve a higher compression ratio while minimizing losses and maximizing the conversion of mechanical energy into increased pressure. 8145. What is one purpose of the stator blades in the compressor section of a turbine engine? A. Stabilize the pressure of the airflow. B. Control the direction of the airflow. C. Increase the velocity of the airflow. The correct answer is B. In a turbine engine's compressor section, the stator blades, also known as stationary vanes or guide vanes, are fixed blades located between the rotating blades, rotor. They play a crucial role in the compressor's operation by controlling the airflow and ensuring its efficient compression. The primary function of the stator blades is to guide the airflow and redirect it appropriately between the rotor blades. As the rotor blades rotate, they accelerate the incoming air and create a rotational motion. However, the air also tends to move in a radial direction due to centrifugal forces. The stator blades help counteract this radial movement and redirect the airflow in the desired axial direction. By controlling the direction of the airflow, the stator blades ensure that the air flows smoothly and evenly through the compressor stages. This helps optimize the compression process and maintain efficient performance. The stator blades work in conjunction with the rotor blades to create a series of compression stages, with each stage increasing the pressure of the air as it passes through. 8146. What is the purpose of the diffuser section in a turbine engine? A. To increase pressure and reduce velocity. B. To convert pressure to velocity. C. To reduce pressure and increase velocity. The correct answer is A. The diffuser section is located immediately after the compressor section in a turbine engine. Its primary function is to slow down the high-velocity, low-pressure air exiting the compressor and convert it into lower-velocity, higher-pressure air before entering the combustion chamber. As the air passes through the compressor section, it gains velocity and experiences a decrease in pressure. The diffuser section serves to reverse this process by decelerating the air and increasing its pressure. This is achieved through a gradual expansion of the airflow area, allowing the air to slow down and undergo a pressure rise. The diffuser section typically consists of a diverging duct or a series of fixed vanes. These components create a larger cross-sectional area for the airflow, which allows for the expansion and reduction in velocity. As the airflow slows down, the kinetic energy is converted into pressure energy, resulting in an increase in air pressure. By increasing the pressure and reducing the velocity of the air, the diffuser section prepares the air for combustion. The higher pressure air is more favorable for efficient and stable combustion within the combustion chamber.